Alright, so we're looking at Unit 8, Lesson number 9, and um, we're looking at the final stress, and that's pressure. A couple of things to point out, and this is important here, that pressure only affects gases. So if you have if you have an equation that has solids, liquids, or substances in aqueous, meaning dissolved in water, pressure is not going to have an effect on that. Well, how do you determine what direction it shifts in? Well, two things. These are all based on, for the most part, coefficients in your equation. In other words, the number of moles. So when you increase the pressure, the reaction shifts to the side with the least number of moles. I'm going to ignore the gas molecule part. When you decrease the pressure, the reaction shifts to the side with the greater number of moles. Now, is it possible to have the same number of moles on both sides? In other words, for the coefficients on the left side to equal the coefficients on the right side? It is. If that is the case, then changing the pressure has no effect on the reaction, so the reaction will not shift into the left or the right. So I'm going to skip that example because that's not a good example and go on to this one. This is a good example. First thing is you notice that they're all gases, so pressure will have an effect. So again, if you increase the pressure, it shifts to the side with the fewer moles. So let's count moles. The moles are the coefficients that are in front. So if you add up the coefficients, there's a 1 and a 3, so that adds up to 4 moles. There's only 2 moles, which means that when you increase the pressure, it shifts to the side with the fewer moles, which means it's going to shift to the right-hand side. So increasing the pressure, we know, shifts it to the left. What will happen, the concentration of which species will increase initially will be the NH3, because whatever side it shifts to goes up in concentration. If you decrease the pressure, it's going to shift to the left. So what will decrease is the NH3 will decrease, and the N2 and the H2 will increase. And that is basically it. One other thing I don't think is on this, so I'm going to just go through it anyway. What effect will adding a catalyst, have on this? A catalyst has no effect on equilibrium. So they might try and fool you on it, saying, if we put a catalyst, what direction is it going to shift in? It's not going to shift in any direction because a catalyst speeds up the forward and the reverse reactions equally. So they kind of cancel each other out. And that is the final lesson for Le Chatelier's principle, and there is one more.